I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. I am your host, Jesse Lawler, excited to bring you our 44th episode in this podcast dedicated to the betterment of your own brain by any and all means at your disposal. This week we are having another episode dedicated to Transcranial Direct Current Stimulation, which we've talked about before. It's the application of electrodes to the outside of your scalp with every intention of affecting what's going on inside of your brain. And this time we're going to be talking to a guy who's really at the heart of the do-it-yourself transcranial direct current stimulation movement, a man named Nathan Whitmore, who's heading up an open source project called OpenBrainStim, which describes itself as a project aimed at creating a fully functional, safe, and easy-to-use tDCS brain stimulator for less than $50, which is a pretty awesome goal, and the whole sort of open source hardware, software, firmware thing is pretty cool. One of the cooler aspects of what the internet has brought to us. Anyway, yeah, we're going to be talking with Nathan in a little bit here. If you hang around until the end of the episode, I've got kind of a meta episode of the Ruthless Listener Retention gimmick, where I'm going to tell you what you can do to promote your own wild and wacky ideas for ruthless listener retention gimmicks in the future. And This Week in Neuroscience and all the rest. In fact, let's segue to This Week in Neuroscience.
Smart Drug Smarts. This Week in Neuroscience.
Scientists at the University of Michigan have recently published a paper entitled Digital Colloids, Reconfigurable Clusters as High Information Density Elements. This was recently published in the journal Soft Matter. And this deals with a technology that they're calling wet computing. Basically what this paper is talking about is a new way of storing data in what could be a biocompatible liquid solution. So these water-soluble compounds that they're calling colloidal clusters were observed by scientists to switch between states when placed in a liquid. This would be similar to the states in a transistor that are used by computers to represent ones and zeros, things like that. So basically the way to think of it is that anything that has discrete states could be used to store digital information, and these colloidal clusters seem to have the potential to be doing just that. Sharon Glotzer, who is a chemical engineer at the University of Michigan and led the research, explains, if we could enumerate all of those different patterns or states and understand how you can go from one state to another, then it would be possible to encode information. The more different colors that can be represented by these colloids, the more states you can have, and the more states you can have, the more information you could store. In theory, a spoonful of water containing these nanoparticles could store up to terabytes worth of data. So this is a very early technology from the sounds of it. They're just kind of starting to get their feet wet in wet computing, if you'll pardon the terrible pun. But the idea of a biocompatible storage liquid is kind of interesting. I'm just going to give my $1 million idea away right now because I've had this ever since I was a little kid and haven't done anything with it yet. So if somebody else can beat me to the punch here, go to it. I always thought it would be cool if you had your appendix taken out rather than just kind of like letting that hole where your appendix used to be closed up. If there's something you could put in there that would be useful, use that space like a kangaroo pouch, or in this case, maybe a few dozen terabytes of digital information storage in colloidal clusters. I guess even those of us that haven't had appendicitis, we just are lugging around these appendixes for no good reason. And that just seems like a screaming opportunity to do something better with that space.
Smart Drug Smarts, where we turn information into sound, into bits, into packet data that turns back into bits and sound, and then into neurotransmitters that release funds that release mail-order synthetic chemicals that cross the blood-brain barrier to release augmented performance from your brain.
Okay, so we're about to dive into the main interview here. I got to admit, for myself, I'm a software guy, so software is a very comprehensible thing to me. It feels comfortable. I'm used to kind of mucking around with computer code, but hardware, on the other hand, is a totally different thing. It's like I probably couldn't take apart my toaster and put it back together again. So I have this incredible reverence when I hear about internet-based do-it-yourselfers that are building their own tDCS devices, which is exactly what we're going to be talking with Nathan Whitmore about in just a moment here. But I don't know if those of you who remember the original Back to the Future from 1985 with Christopher Lloyd, when his character first shows up on the scene, he comes to the door and he's wearing this contraption on his head with all sorts of these light bulbs in like a geodesic half dome, trying to read people's minds. And that's sort of the first vision that always comes to my head when I think do-it-yourself tDCS. But I think this technology is probably a lot less madcap than Christopher Lloyd was in that role. And I have actually still not tried tDCS myself, but after having done this interview, I'm not sure that I'm going to build my own, but I got to give this a day at court. I'm going to get myself to my nearest tDCS retailer and give this technology the Pepsi challenge, because I must admit I'm increasingly curious about it. Now let's dive in with Nathan Whitmore.
Smart Drug Smarts.
This is actually our second episode related to transcranial direct current stimulation, but for the people that didn't make it for the first episode, could you kind of give us an overview of the technology and kind of what tDCS is in a nutshell?
Okay, yeah. So tDCS is just a fancy term for running a very small amount of electricity through the head. And why people do this, the strange thing, is that when you do this, you send a little bit of that electricity through the brain, and that can actually alter the behavior of nerve cells. Depending on if you're sending a positive or a negative current, you can make those cells more or less likely to fire. And it turns out that how likely nerve cells are to fire has to do with a whole bunch of things that people who are interested in cognitive enhancement might care about. So for instance, by doing this, you can improve your working memory, your short-term memory, help yourself concentrate more, treat depression. It is actually a very flexible thing. You can do a lot of different things with this very simple technology.
So there's these sponges that go in different places on the scalp that have some sort of liquid on them to make them conductive.
Yeah.
Is there sort of like a head map of where you're putting different sponges to get these different effects?
Yeah, so what people use to position the sponges and to make sure that you're positioning them in the right position is something called the 10-20 system, where you either put on a headset that's calibrated to have like attachment points at the right spots on your head, or you measure a certain percentage of the distance from your nose to the back of your head and between your ears, and that gives you a coordinate system. So when you see a study that says we put an electrode at F3 and it improved cognition, anyone can then find F3 on themselves and put an electrode there.
Very interesting. It reminds me almost of the weird, phrenology experiments from like the 1920s and 30s, the idea that different bumps on people's head can have effects on their personality.
Yeah, in a way it's very similar to that, because oftentimes the reason that we say to put the electrodes on a particular spot is because we have data from MRI that says that spot lights up when you're doing a task, and you say, okay, maybe we want to improve your performance on that task, so let's see what happens if we make that spot light up artificially. So in a way, you're looking at this kind of anatomical thing, and you're saying, oh, you're trying to tie it to cognitive performance. It works a bit better than the phrenology, I think.
What sort of divergence is there between one person's brain and the next as far as where some of these points might be?
That's a really actually interesting question in the context of this thing, because it turns out that one of the biggest differences in that is whether you're left or right-handed. If you're left-handed, you will have a lot of things that are normally on the left side of your brain for right-handed people. If you're left-handed, there's a chance that those will be on the right side of your brain, or they'll be kind of mixed in between the two hemispheres. And this is not like the anatomy. This is kind of what functions the different parts do. And this is actually why, if you're in a brain study, lots of them just exclude left-handed people entirely. That's actually a concern for left-handed people who are doing tDCS, because if you're left-handed, we really don't know very well how your brain is organized.
Wow, boy, that seems like a major oversight at this point. There's a lot of lefties out there.
Yeah, I mean, it's kind of how neuroscience works, is that first we want to kind of figure out how the brain of a prototypical human works, and then kind of deal with all the messy human diversity of it. And there's good sides and bad sides to that approach, I think, but that is how it is.
Yeah, well, thank you for the explanation. So tell us about OpenBrainStim and sort of when you opened the doors on that and sort of the goals of that project.
Okay, I started working on that project several years ago, and it came after I had kind of an unsuccessful attempt at building this other kind of brain stimulator, which now seems to be complete pseudoscience, which was why it didn't work. I read one of the very early articles about how people had been using this thing called tDCS to improve math performance. And I'm not actually that great at math, so I was like, oh, that looks kind of interesting. And then I looked at it, and I'm like, whoa, actually, this is really simple. I could build one. So I built a very simple brain stimulator. It was also very scary and dangerous, as it turns out. And I tried it out. I got interested in it. I started looking around at kind of what people were doing, and I saw that like people are building these kind of simple stimulators, and there are also these commercial stimulators. So I was wondering, could you make something that someone could build that would also have like the features of one of those commercial stimulators? And that was where I kind of got the idea from OpenStim, was to kind of take the idea of these DIY stimulators to the next level.
So that was a couple of years ago now, and you've built a small online community around that?
The community kind of happened on its own. Like when I first started doing it, there were maybe a couple dozen people on the internet who were doing similar things, and now that's grown to like several thousand. It's pretty crazy.
That's awesome.
What was interesting is actually like when I first released the OpenBrainStim, no one was all that excited about it, and it was really this year, I think, with a lot of the publication and kind of popular media excitement about tDCS, which when it really started taking off.
You recommend running any sort of tDCS system from your laptop while not plugged into the wall. Can you go into the details of some of the safety considerations? Okay,
yeah. So the main reason that you don't want to run plugged into the wall is that there's a low but entirely unavoidable possibility that there would be some sort of power surge. And if your laptop is plugged into the wall, that surge could theoretically climb up through your laptop's cord and then through the cord that's connecting the stimulator to you and into your brain. And at that point, lots of bad things could happen. As long as you are not connected to that kind of mains power source, your laptop's battery is actually very safe, or you can load a program kind of directly onto the board's memory and then just run it off a regular 9-volt battery.
How many amps are we talking about here that are actually passing into the head?
So in OpenStim, usually reaches its maximum depending on how much resistance your skull and your skin has. The maximum will be about 2.5 milliamps. So to put that in perspective, that's about a tenth of the power that it takes to light up a single LED. I mean, that's, I think, where some of the confusion here comes from about the safety of tDCS, is that people think of it as a form of something like electroshock therapy, which actually uses an amount of current that's 100 times what you see in tDCS.
Right. It's not exactly like putting a lightning rod on your forehead.
Exactly.
So what are some of these like subjective benefits that you've received personally from tDCS?
The coolest one that I like to talk about is I was trying to do a protocol that is supposed to improve your working memory by making your prefrontal cortex more active. And unfortunately, when I was trying to do this, I had the polarity reversed. So I was actually making my prefrontal cortex less active. And before I knew this, what I was doing was I was working on this programming problem. I had not been able to figure it out for like a week. I turned the stimulator on. It's actually shutting down my prefrontal cortex. And then all of a sudden, like, the computer feels like it's programming itself. And I just kind of like fly through this problem. I get it. It's a flow state, essentially. So what I think is happening actually is if you have something that the prefrontal cortex is good at kind of helping you learn to do new things, but if you have something that you're already good at doing, it interferes. So if you can shut it down when you're doing something you already know how to do that's already established, it lets more efficient parts of the brain take over, is my hypothesis.
What's the level of sort of community involvement at this point online, not necessarily with the building of the devices, but with the comparisons of subjective effects from applying current to different areas on the scalp?
I think there's a lot of that happens, especially on our subreddit. It's reddit.com/r/tDCS. It's hard to say how useful it is because it is usually sort of like forum posts, people talking about their particular subjective experiences. One thing that I'd like to either set up if I ever have time to, or see someone else set up, is actually kind of a systematic way of tracking the effects that are associated with particular places where current is delivered, because I think that would actually be something that would really benefit the community.
What are your goals for developing online community over, like, let's say the next year or two?
I think that one of the most important things with the DIY tDCS community, and actually just the community of people who are using commercial devices to kind of do their own therapies and experiments on themselves, is defining some sort of standard for the safety of devices in use. Because what we're having right now is kind of this explosion of available devices, and it's very difficult to compare the devices and figure out how safe they actually are. So one thing that I think really should happen and needs to happen and will eventually happen is kind of crowdsourcing a set of standards that you can apply, safety standards and efficacy standards that you can apply to any device. And you can then say to everyone, this device is pretty unsafe because it doesn't meet these parts. And I think that is going to be incredibly important just in terms of the ability for people to trust tDCS devices and also not to get hurt using them.
How many retail devices are available out there? I know that there's the one for Focus. That's the only one that I've heard about. But are there many others?
There's 3 or 4 devices right now that are specifically marketed to end users for tDCS. There's the Focus. There's the Transcranial Technologies Stimulator. There's one that's just called the Brain Stimulator. Those are the main ones. The other thing that people will use is a device called an iontophoresis machine, which delivers current in the same way as a tDCS device does, but it wasn't built for that. It was actually built to deliver medications across the skin, but it works, so people will use that too.
How long is a tDCS session normally?
So in research, you can do anything from typically you'll see 5 to 20 minutes. For people who are doing it to themselves as a DIY thing to improve performance, it tends to skew towards the upper end of that. So maybe 20 to 35 minutes, I think would be the typical range. The idea is the longer you do the tDCS on yourself for, longer the effects last after you turn the stimulator off.
And what is sort of the timeline to drop back to sort of baseline levels of potentiation within the brain?
So that's actually a really interesting question. Because the question is how do you measure that? And it turns out that we can really only directly measure kind of the excitability, which is how likely neurons are to fire. We can really only directly measure that in a couple parts of the brain, like the parts that control motor activity. So when you do that, what you typically see is that you have most of the benefits or most of the effect of tDCS is gone within about 2 hours after the stimulator is turned off. But on the other hand, you have trials now where they're using it to treat depression. And what you'll have is that people will go in, they'll get tDCS for 20 minutes every 2 days or so, and then over a long period of time, their depression symptoms improve. So what that suggests to me is that maybe in other parts of the brain, that effect can last much longer, or maybe there's effects that are not what you're measuring just with that simple test. For example, changes in gene expression, changes in myelination of neurons that occur over a longer time scale.
Have there been any instances where somebody has hurt themselves using tDCS?
Kind of. The worst thing that seems to have happened, with the current generation of tDCS devices, is that you can get burns on your skin. And that usually happens if you're using electrodes that are too small. So, for example, the Focus has very, very small electrodes that go on your forehead. So when they started marketing it, we started seeing a whole bunch of reports of burns from it. And that's because you're forcing current through a small area. But the damage from that seems to be confined to the skin. There's no evidence that it actually hurts the brain. There was some concern a while ago that if you sent current through your brainstem, you could actually interfere with the neural systems that generate breathing. There was a single case report in the 70s that showed that, but people tried to replicate it and they couldn't. So generally, in terms of your brain at least, this is actually thought to be very safe.
So if somebody hasn't really been involved, hasn't known anything about tDCS prior to hearing this interview, and they hear this and they get all excited, what's the best place for them to start?
Okay, so I mentioned the tDCS subreddit a while ago, and that's this website. It has a lot of people discussing tDCS, but we also have basically a wiki site that has a list of frequently asked questions and like things that people getting started want to know, everything you want to know about safety and kind of what devices actually seem to work well. So I would really advise them to check that out, and if they have questions, actually post on there too, because there's a lot of people who are very experienced and or will be much happier to help you out than have you fry your brain doing something wrong.
Smart Drug Smarts.
So thank you very much to Nathan for joining us for that interview. I will put a link to the OpenBrainStim project and sourceforge.net. SourceForge is actually worth knowing about if you're a sort of a technical geek or a do-it-yourselfer. It's a site for all sorts of different open source projects. Looking at it now, they've got over 4.3 million downloads and almost 15,000 code commits. So a very active online community and well worth knowing about if you're into such open sourcey stuff. Also, a little fun fact, I couldn't think of a particular correct spot to put this in the Smart Drug Smarts episode format, but something I did want to tell you guys is that starting actually with last episode, we're going to be doing transcripts, text transcripts of each of the interviews, and in fact the whole Smart Drug Smarts show from episodes number 43 on forward. We're not going to go back and do the historical episodes into the yesteryear of Smart Drug Smarts, but from now on that'll be part of our normal publishing processes to get the text transcript as well. So if you want to read rather than listen, or you want to have a quick way of sort of text searching to go to a particular topic, that will now be at your fingertips.
Smart Drug Smarts. Ruthless listener retention gimmick.
And as promised, in our ongoing efforts to make the Smart Drug Smarts website a cooler place to be, and make this podcast a cooler thing to listen to, we just added a suggestion box at smartdrugsmarts.com/suggestion-box. Put a link to that, which is what you would imagine, basically just a page where you can go to if you see something like when you're reading around on the web that you think might make a good This Week in Neuroscience article, or even a oddball thing that might be a good ruthless listener retention gimmick, or you see a study that you think would maybe merit being a conversation topic for a primary interview for one of the podcast episodes, definitely let us know. Just go to the Smart Drug Smarts suggestion box page, drop us the link if you want us to name your name on the show. If we use your suggestion, more than happy to do that. So yeah, I mean, as I've said before, I've gotten a lot of great ideas for different episodes based on emails and comments and stuff like that that have come in from the listeners. So keep those coming, and now we've got sort of a more organized format for you to submit ideas through.
Smart Drug Smarts, the podcast so smart, we have smart in our title twice.
All right, that is the entire episode number 44. Cruising in for a landing. If you liked what you heard here, please take a moment to recommend this podcast to your friends, your enemies, your neighbors, your mailman, your grocer, anyone you know who has a brain. The show notes for this episode will be online at www.smartdrugsmarts.com, including the links to everything we talked about here and the handy-dandy new little format that we've got that gives you the minute and second of the different topics that we're talking about, so you can kind of skip around and go to just the juiciest bits. I will be back at you next week at the approximate same time and the exact same podcast, and with an unchanged commitment to helping you fine-tune the performance of your own brain. Have a great week and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.